Okay, section 3, question 3. The graph of the cubic function y equals f of x is shown in the diagram. There are turn points at 1, 1 and 3, 5. Sketch a graph of the derivative y equals f dash x. So a turn point is a stationary point, and that's a point of zero gradient. So the turn points of zero gradient, the stationary points are at 1, 1 and 3, 5. To sketch the derivative, what we'll do in a question like that is we need to basically draw a new curve of what the gradient of the curve looks like. Now, the way we do so is to set up a table and we look at x values, and what's required is that we look, observe and record the gradient before stationary points, at stationary points, between stationary points and after stationary points. So that's really just before the gradient changes from positive to negative and zero. Before that happens, between when it happens, at when it happens, and after when it happens. So I'm going to set up a table for x and f dash x. So x is going to be referring to the x coordinates, f dash x is going to refer to the gradient of the curve. Is it positive, is it zero, or is it negative? So I'll look at the x coordinates before there's a change in gradient, before turning points, at turning points, between turning points, and after turning points. Now, the first turning point occurs at 1, 1, but it's the x coordinate that I'm interested in. So the first change happens at 1. So I want to observe what's happening before that. So that's before 1. Then I want to observe the gradient at 1. Next thing I want to do is to look between stationary points, so that's between 1 and 3. Okay, another stationary point at 3, so I want to look at 3, and then finally I want to look after 3. So it's about recording in a table observations about the gradient. So before 1, pretty clearly, if I look before 1, that curve's going downwards, therefore I can say that the gradient is definitely negative. 1 is a stationary point, point at zero gradient, so I record that as zero gradient. Between 1 and 3, curve's going upwards, that's positive gradient. At 3, that's a point at zero gradient again, so I record that as 0. And finally, after 3, what's happening is the curve goes back down the way, and I'll record that as negative gradient. So remember, f dash x is a measure of gradient. Now, what I'm going to do now is to sketch what the gradient looks like. Now, a good way of doing this is, first of all, record points of zero gradient. So this time what we want to think about is this line, this vertical line here. It's no longer a line which represents y coordinates, it's now a line that represents the gradient. So almost like a thermometer records heat. Well, anything up here would be above 0. Anything down here would be below 0, and that would be freezing point at 0. Well, for y coordinates, anything up here is a positive y coordinate, down here is a negative y coordinate, and 0 y coordinates, but this axis doesn't record y coordinates just now, it records gradient. So up here is positive gradient, down here is negative gradient, and on here is 0 gradient on the x-axis. You can first of all see that I've got 0 gradient at an x coordinate of 1. I've also got 0 gradient at an x coordinate of 3. Now what I must do is my curve must go through that point and that point, because I know them exactly. I've definitely, an x coordinate 1, I've definitely got 0 gradient, and an x coordinate 3, I've definitely got 0 gradient again. Now, before 1, what's happening is I've got negative gradient. So I don't know exactly what the gradient is at any given point there, but I know it's negative, so negative gradient is going to be below the x-axis. So before 1, I'm going to say I'm in this area. negative gradient before 1. Between 1 and 3, the gradient's positive, so that's up in this area somewhere, and after 3 I'm negative again. Now, best way to do these questions then is you need to make sure that you go through here and here, your points of zero gradient. Now, these bits here, I just use these as a kind of guide as to where my curve goes, so I shouldn't necessarily try and join these bits up, but I'm looking more that just to have a kind of nice continuous curve that goes through here and here, and is in this area, and this area. That's pretty simple. That just gives me something that looks like that. And there's the gradient of the curve. Okay, section 3, question 4. The diagram shows the graph of y equals f of x, where f is a logarithmic function. So you can see that the curve goes through 4, 0 and 6, 1. What is f of x? Is it log to the base 6 of x minus 3, log to the base 3 of x plus 3, log to the base 3x minus 3, or log to the base 6x plus 3? The first thing that we should observe is an unadjusted logarithmic function of log to the base a of x should go through 1, 0. Now, if this one actually goes through 4, 0, it means it's been shifted 3 units to the right. 3 units to the right, if we think about that in terms of in the bracket, you go against the grain, so positive to the right by 3 would indicate moving x minus 3. So I think at this point we can rule out B and D. Now if you now kind of think backwards in terms of where this thing would have went before it gets shifted 3 to the right, that's what it would have looked like. It would have went through 1, 0 and 3, 1. Now that suggests that it's log to the base 3 rather than log to the base 6, because log to the base 3 of x goes through 1, 0, 3, 1, log to the base 4x goes through 1, 0, 4, 1, log to the base 10x 1, 0, 10, 1, log to the base a of x goes through 1, 0, a1. So by process elimination we can say with confidence then that the correct answer is option C.